So sorry for that delay. That's now we can see both the rotation of the floor plates and the curve in the full tower. Now we've taken the floor axes that are being rotated, and actually let's just kind of re-examine this again. I'm going to turn the preview off for this. I'm going to turn the previews on for this so we can see that's the floor plates all being rotated. And I say floor plates are still really just 4 NURBS curves. We haven't made a surface out of them. And then we're going to, if I turn on this preview, now we're seeing the rotation and the offset of the NURBS curves. And then finally I'll turn that off and turn on the translate, where we're actually moving up through the z-axis in space to create the tower. So now we have really 80 NURBS curves. There's no surfaces. They appear to look like they're closed circles, but they haven't been defined that way yet. And the next thing we want to do really is to skin the outside of this. And the way we're going to do that is to select all of the outside NURBS curves. And that's probably one of the more interesting parts of this project. I'm going to zoom in here. I want you to be able to see that this list is a list of lists. So we have each list has 2 components. Each list of lists has 2 components of 2 components that are, so we have a fully nested set of elements, which is relatively complicated to work with, but they're in a very understandable order. We know that like NURBS curve 1 and the next list down of the, let me pin this. This NURBS curve, which will highlight down here. I'm not actually able to show it here. Let's see if I can show it. And then this NURBS curve here are probably the 2 outside NURBS curves that we want in order to find the skin of our building. So we need to actually just parse through our list of curves in order to find the geometry that we want. And Dynamo gives us a few tools that we can use to accomplish that. So we're going to go up here and look now, and what we have is the idea of selecting those edges, those outside edges. And I'm going to do that just by flattening this list. So now all of our NURBS curves are completely flattened. There's no list within list. And while that might on the face seem like it's more complicated, we realize that there is a logical order to the way all of these NURBS curves are aligned, and it's just our job to pick out the right ones. So we know that basically we have list of 4 curves that we want to parse through. So we're going to go through sets of 4. So we're going to take every item at this idea of a 4th interval, and the items we're going to take are the first item and the 3rd item. Well, I guess as you know, 0 is always the 0 position item, and then so 2 is the 3rd item. And with that idea, now we've parsed this down to a list of 40 NURBS curves. And if I select and bring these together, I can then generate our surface. So I'm going to go ahead and turn this surface on. Oops. And now we have our outside surface. Now this is kind of a fun thing to experiment with, and I think this is probably the thing that you should devote maybe the more time to kind of experiment with. There's many ways you can parse this list to find these specific discrete curves that you want to link together to make your lofted surface. And if we're not familiar, the idea of surface by loft is we're taking each cross section along here and putting them together to generate a NURBS surface. But if I was to, for instance, make an error with this, and this runs just a little bit slow, so bear with me here. I'm going to let that run, and I've actually now just messed up the order of the way the NURBS curves are related to each other. And that's going to generate a whole different kind of surface set. And there we go. So I'll go ahead and hide the code here. So this is just a mistake, but it's a mistake that helps to visualize what's going on here. So in this case, I picked NURBS curves at an interval of 3, so I'm getting kind of an undulation. I'm picking inside curves, and then I'm going out and picking outside curves, and the resulting shape actually quite interesting, but not the desired one that I wanted. So if I will have to go back and correct that by picking this idea of the fourth, going in increments of 4, picking the 0 item and the 2 item, or the first item and the third item. So anyway, I'll rerun that again, and what I would try to turn, I'm going to leave this off because we know what happens at this function. Well, we'll see. I'm going to go ahead and run this. Hopefully it won't take long to get back to where we were. So that clicked out to Revit, so maybe it completed that. So there we now have our surface. If I turn on our panelizing, I'm not sure this is going to actually show us much, but this is the lunchbox tool for panelizing, and you can actually see it. You can now see the points that lunchbox is ordered for, and you can see the number of panels. And in this case, I didn't assign very many panels. I assigned 20 in the V direction and 10 around the face of the building in order to create all the panels. And that's what we're going to actually create into glass. And the reason I picked panels, we could have added surface by loft right to glass, but that wouldn't have been even rational for the idea of panelizing a curtain wall on a building. So anyway, this gives us a way of at least simulating the idea of faceted construction, a panelized curtain wall. And the other thing we need to do is we can take that same floor geometry, the NURBS curves, and in this case we have, looking back at this list, because really what's most critical about this whole, I guess, process is the idea of the way we understand and process lists of information, of curves and points. So we still have, though, the idea of list of lists. So we have our 40, we actually have 80 curves, but we have 40 lists with 2 curves in them. And we feed that into our cross sections, so we'll get out 40 cross sections. So we end up with 40 surfaces. And then we feed those surfaces into something to thicken them, and I'll actually turn off the panel quad, and I'll turn off the surface by loft. And now we just have the NURBS curves, and I'll preview them when we actually add a material and a thickness to them. So I've still got something highlighted here. I'm going to turn this off. There we go. So we can actually, and then let me just zoom in here so we can see that these are actually thickened floor plates. And my mouse is, or my dynamo has gotten a little unresponsive. Anyway, so our final step now really is we have our floor plates defined, we have our panel facade defined. I'm going to turn the preview off on this so it doesn't show through to Revit. And we're going to feed panels into the geometry of direct shape by geometry for the glass. And I've given that a glass material name. And then for the floor plate, I've got the same functionality, except that the material name is now gray. And we could go ahead and run that. And that's going out to Revit, so that might take that might be a bottleneck. So I'm going to actually end this. I'll let that go ahead and run and play out, and then we'll tie things together in the last clip.